Today we are going to learn about IP addresses and subnets. So this is a very essential topic and a topic where people get confused a bit whenever they learn networking on AWS, Azure or any public cloud or even on-premise. Okay, so these things are common and hence IP addresses and subnets. Okay, what are IP addresses? So we will start discussing about what IP addresses are. So what do you mean by IPv4, IPv6, and what is CIDR? What do you mean by classful network addressing, and difference between network identifier bits and host identifier bits in a IP address. Also subnetworks and netmarks, and even the significance of private IP addresses. And what you need to know, basics of computers and computer networks, binary, decimal and hexadecimal numbers. The knowledge should be good, but it is not mandatory. Adding of binary numbers, again, that knowledge will be good. Understanding of OSI model and TCP/IP is good to have, and understanding of router, switch, bridge and all are also good to have. But don't worry, if you don't know any of these things, you can let me know, and then as part of our Computer Science Connect, I'll be taking sessions from those topics. Okay, so do let me know whatever topics you are not familiar and would like me to take a session on. Okay, and so this is our agenda for today. Know your teacher as usual, because you should feel that I can teach you something. But since this is not the first session of the series with respect to the cloud sessions, I will keep it limited. I'll just run through it, and announcements and thought of the week again. So this is still part of the last week. So from a session perspective, our week starts from Saturday morning. Okay, so we will still have the old thought of the week, and we will learn about IP addresses, and quiz championship will be slightly different today. We will not have our usual poll everywhere quiz. We will use pen and paper to actually answer those things related to IP addresses and calculations. And then tomorrow morning anyway, we are going to have our normal poll everywhere quiz. Okay, know your teacher. I'll run through. I'm an author, architect and tech evangelist, a few master's degrees, certifications, and work with some good companies, and still working. I've written few books. One of my books got listed in best cloud computing books of all time by Book Authority. I speak in meetups, conferences. I take webinars for engineering colleges and students and teachers, and I read a lot. And my goal for 2020 is to teach 100,000 students. If you all help me, then I can teach them. So there is no fear or anything. You have to just come and learn. And I get paid for my work, so I don't look for getting money out of these courses. And I also get paid for my books as royalties. So this is one question I get always, that why you conduct trainings for free, is there any catch? Okay, announcements and thought of the week. Again, so this is part of a certification preparation course, so we will not go very deep, but again we will learn most of the important things that is required. The more knowledge you acquire and the greater skill that you apply, the more competent and valuable you become. Okay, so you need to learn more, improve your skills, then only you can be better than others. Okay, and then you have to do this along with like cooperation and collaboration with others. And so this is also one such exercise where you are going to improve your skill on some networking concepts, even though it is not purely needed for exam. IP addresses and subnetworks. Okay, how many of you know what is an IP address? You can say yes, no, anything. Okay. Yeah, people are all messaging about the changes in Azure certification. Uh, Again, so it is a good news that okay, it is not going to change immediately. We will evaluate it after this for sure. Okay, so coming back to IP addresses, yeah, not in detail. Unique address given to a system. Okay, so an IP address is a numerical label assigned to each device connected to a computer network that uses internet protocol for communication. Okay, and some of these things you will understand only if you understand all the layers of the OSI model. Okay, layers of the OSI model we will learn in a different session in detail, but knowing IP addresses and CIDR and subnets are enough for working with cloud at this moment, but we will learn everything, and then the more we learn, the better we can work on cloud or anything around those areas, especially related to networking. And IP address fulfills the functions of identifying the host and locating it on the network. So it is like an address. So all of you will have address, right? All of you will have address where somebody can post messages or post mails, and then you will receive it, or you order something from shopping websites and then receive it. So all of us will have some kind of address. Similarly, every device in the internet has an address, and that address is called as a IP address. Okay, and again you can have static IPs, or you can dynamically configure. You can configure to dynamically assign an IP. So there are like multiple different ways to configure an IP. In any case, you will need an IP to communicate with the internet. Okay, and then there are two forms of IP currently available. IPv4, which was the original or the earlier version of IP, which was more popular until recently, and it has 32 bits. Okay, the problem was that with 32 bits, the number of devices that can be connected to internet was getting limited, and hence we were all looking at how things can be improved, and then eventually IPv6 came, which is 128 bits, and it will take a long time to fill up all those 128 bit permutations and combinations, right? So, and again so because of the fear and scarcity of 32 bits of IPv4, we also have came up with the concepts such as private IP addresses and all, which we will see in some time. And again, so IPv4, it is 32 bits, and it is divided into 4 octets. What do you mean by octet? An octet is a 8-bit aggregation, and similarly IPv6, it has 128 bits, which is divided into 8 hextets. What is a hextet? It is a 16-bit aggregation. Okay, there is a typo here, I'll correct it. And so here is the question: what is the maximum decimal number that any of the 4 parts of an IPv4 address can hold? Okay, can anybody tell? Okay, we learned about a few things. We learned that okay, it is 32 bits, and it is divided into 4 octets. Each octet is an 8-bit aggregation. So tell me. Okay, Naga, you can answer to everybody. So Okay, the answer is, so the maximum you can have is 255, and that is because it is the largest binary number that can be represented by 8 bits. If you use a online calculator that converts binary to decimal, you can see that if you put a binary number with 8 ones and then convert, it is 255. Okay, now what is the maximum decimal number that any of the 4 parts of an IPv6 address can hold? Okay, again another typo, because I quickly made this PPT yesterday night and early morning today. So it is not a maximal decimal number, it is a maximum hexadecimal number. So I need some answers. You can use Google if you want, but I need some answers. What is the maximum hexadecimal number that can be formed using how many digits? At least, okay, yeah, Bonnie said it is FFFF. Okay. Yes, okay, it is FFFF, and so this is a number that once you convert it, it will give you FFFF. Okay, so these are some of the things that we will do today, and that is why I asked you to I told you that it is good to have some understanding of binary, hexadecimal, decimal, and all those things. Okay, so now coming to classless interdomain routing, or CIDR. Okay, so it will be only effective and interesting if more people answer. Okay, so until now I am hoping you understood things. So now it will be more interesting, and because of that I would need you all to concentrate, take a pen and paper, and then try to answer. Okay, CIDR is a method for allocating IP addresses and for IP routing. So this is one of the current ways in which you can represent an IP address space. Okay, we will see what is an IP address space, and before this we had a classful classification, which we will anyway see just for reference purpose. And so in this, whenever you say the CIDR format or IP address in general, you can divide the IP address into 2 parts. Okay, the most significant bits is called network prefix. It is actually used to identify a network, and the least significant set is called host identifier. Okay, host identifier means within a network I need to find the device, and it is used for that purpose. Okay, so imagine that I have two digits in host identifier for a for an IPv4 address. So how many digits will be there in the network prefix? I need answers. So okay, I have 2 bits. I have 2 bits in host identifier. How many bits will be there in the network identifier or network prefix side? I have 2 for host ID. So how many for network ID? For an IPv4. Okay, everybody, people are sending to all panelists. Don't send to all panelists. Select all panelists and attendees and send. Okay, because this is going to be a good learning. If you are planning to continue your career in Azure or any cloud, of course you will need to work with the virtual networks, create subnets on your own, and do all those things. Even otherwise, knowing these things are very good, even from an interview perspective also. Okay, so people are telling 3, 2, 6 and all. How many bits are there in a IPv4 address? We learned just now, right? How many bits are there in a IPv4 address? not 256, 32 bits. Okay, 32 bits are there in a IPv4 address. If two of those bits are host identifiers, what is the network prefix? Okay, Ashley has given the first correct answer. It is 30. Okay, so total you have 32 bits, and out of that 2 bits are host identifier. So whatever remaining is network prefix or network identifier. Clear? Are you clear? Because we will have a lot of problems like this, lot of questions like this. Okay, so again, yeah, Shruti, I can explain, because we are not going to learn a lot of things, but whatever we learn today should be thorough for you. This is even for people who work on clouds, work on AWS or Azure or any cloud, have confusion about CIDR, subnetting and all. Okay, so it is always good to learn something thoroughly, and that we will learn today, and that will only happen if you answer. Irrespective of whether it is wrong or not, you have to answer, everybody. Okay, so IP address has so IPv4 or IPv6 has a set of bits, and the most significant bits, any number, will be called as a network prefix, and the rest of it will be called as a host identifier. So network identifier and host identifier. So network identifier plus host identifier will be 32 bits in case of IPv4, or 128 bits in case of IPv6. Okay, that much you understood, right? So, and this network prefix or network identifier part is used to find a network. Okay, the network can and within the network you will have a host. Okay, you will have a big network like Amazon and all, and Amazon will have its own internal host. Okay, so the internal hosts will be having their own and it will be created. Okay, internal hosts will have their own IPs, and then IPs will be calculated or assigned based on the host identifier bits. Okay, so if you have only 2 host identifier bits, as in this case, how many IP addresses can I have? Okay, if I have just 2 host identifier bits, how many IP addresses can I make with that? Can somebody at least make a guess if I have only 2 host identifiers? Okay, Anida has mentioned 4. So the answer is 5, 4. Okay, so okay, the question is if I have 2 host identifier bits, because host identifier bits are the bits that vary. Okay, in other words, host identifier bits are the bits that vary whenever within a network. Okay, so within your network, imagine that you have a network, and within that network you have only 2 host identifier bits. So how many IP addresses can you have within that network? With those 2, you can only have 4, right? Okay, it is 2 to the power of 2, which is 2 into 2, and it is 4. Okay, so again, I should have mentioned little bit of permutations and combinations and mathematics would be good to learn. Again, so here you need to know only this 2 to the power of n thing. So you can revise your permutations, combinations and all from college days. Okay, in CIDR notation, an address or routing prefix is written with a suffix indicating the number of bits of the prefix, such as so here 192.0.2.0/24 for IPv4 and /32 for IPv6. So these are just 2 examples of representing an address space. So this means that 192.0.2.0.20/24 means, what is this 24? Okay, yeah. So in people are telling subnet, host identifier. Okay, so it is also called as a subnet mask, but it is not a subnet. It is called as a subnet mask, and we will do some problems and it will be a little more clear. Okay, so what do you mean by routing prefix? So routing prefix, is it the NID part or the HID part? Is it the network identifier part or host identifier part? The routing prefix. Can anybody guess? You might have seen the previous PPT, but can anybody guess? Is it the routing prefix from the name? Can you guess whether it is a network identifier part or host identifier part? Okay, yeah, Kranti has mentioned it correctly. It is the network identifier. So the routing happens. So why do you route? You route to find a network or a subnetwork. Okay, subnetworks comes after we subnet create subnets. Okay, routing happens while we look for a network or a subnetwork. So routing prefix means if there are no subnetworks, it is the network identifier, and if it is if we have created subnets, then it will be a combination of network identifier and subnet identifier. So what is remaining will be what? Host identifier. Okay, you have routing prefix which has network identifier and also the host identifier, no, network identifier and even subnet identifier, and the remaining will be your host identifier. So don't worry if you are not getting it. I'll make sure you understand all these things before you leave today. So again, CIDR. So yeah, I take sessions on CI/CD pipeline, and then by accidentally I say CI/CD. Okay, so excuse me. This CIDR, and it introduced lot of other things also, such as administrative processes and all to this IP allocation process. And so CIDR is supported for both IPv4 and IPv6, but the classful one, which is the older one, is supported only for IPv4. Okay, and so this also allows you to because with IPv4 the classful classification, you needed to have lot of entries in your routing table, but here you can combine many things easily. We will see how we divide, so then we will get an idea about how we combine. Okay, and then the routing, the number of entries in the routing table will be less, and it is used extensively to represent. It was okay classful network addressing. It is just for reference purpose. We don't use it a lot these days, unless it is a legacy network. So it was used commonly until CIDR came in 1993, and it has classifications such as A, B, C, and all. And there was a class called D, which was used for multicast, and class E was reserved for future or experimental purposes. Again, we won't go into deep because that is not needed for current. Again, if you want to learn, so class A NAD had 8 bits, HID had 24 bits. Again, class B, so these things were fixed. Okay, NAD has 16 bits, HID has 16 bits, and also there will be a prefix. Like in class A, the prefix was 0. In class B, it was 10. So whatever remaining can be only used for all the permutations and combination. And class C, you had 24-bit NAD and 8-bit HID and prefix of 110. Class D and E does not have NAD and HID separation. So, and current users, it is mostly for legacy networks. And classful network and CIDR comparison. The classful network designed for IPv4 size the network prefix as one or more 8-bit groups, resulting in blocks of class A, B, and C as we saw. So, but in CIDR, so it is not based on any predefined thing, so you can have other divisions also. It is not purely classified based on 8-bit groups. As we saw, you can have /24, /25, /26. You can have all the options. Okay, it is not exactly classified with 8-bit groups and then put into some predefined set of addresses. Okay, so this in Classful, there is either you can have a little bit or you can have a lot, but you cannot have anything in between. So all those things won't happen now. So again, IPv6 will have certain limitations. Again, these theory things you can always learn, but the important thing is to understand how we can create subnets using CIDR. Okay, and NAD bits and HID bits. Before that, let me check. Okay, there are no doubts. Okay, NAD we understood it is also called as network prefix, and it is the first part, and second part it is the HID bits, which is the host identifier. And for an IPv4 address, the total number of bits is 32, you know. Therefore, if NAD has 24 bits, the HID will have 8 bits. And for IPv6, the total number of bits is 128. For an IPv4 address, if NAD has 24 bits, HID has how many bits? Okay, so first person to answer. Okay, yeah, Bonnie answered first, then Ashley, Sruthi. Okay, so you have to be attentive, and we'll be checking all the answers later. Okay, so it is 8, very clear. And for IPv6, if NAD has 32 bits, HID has how many bits? Let me check whether you are still good in mathematics. NAD has 32 bits, HID has how many bits? Okay, yeah, this time Ashley said it is 96. Sruthi, Marin, everybody said 96. Okay, mathematics I will not teach you. I will ask my baby girl to teach if you don't know subtraction. Okay, so again, most of you answered it correctly. And now, number of IP addresses in a network. Okay, so the number of IP addresses we already saw. Number of IP addresses possible within a network can be calculated from the number of possible combinations of HID bits, because the NID bits or the routing prefix is fixed for your network. Okay, you cannot change any of those things. You can only change the remainder of the things. Okay, so and you also know how to calculate it. It is 2 to the power of n. Okay, if you have 2 bits, it is 2 to the power of 2. If you have 4 bits, it is 2 to the power of 4. If you have 8 bits, it is 2 to the power of 8. Okay, so okay, again, another, it is actually a typo. It is calculated as 2 to the power of 4. What is 2 to the power of 4? Yeah, 16. Okay, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. Okay, I'll just correct it. Okay, yeah, so that is fine. Okay, so now if the number of HID bits is 8, then how many different IP addresses are possible? Okay, so this has mentioned 64. Okay, 255, 256, 255, 256. Okay, let us see. It is 256, which is calculated as 2 to the power of 8. Okay, so again, you shouldn't be making mistakes on simple mathematical problems. If the number of HID bits is 8, then how many IP addresses can we have for IPv? Okay, so again, so this is a concept I did not tell you, so don't worry. So in general, two IP addresses will be blocked. So if the question is how many IP addresses can we have, then it is 256. But if the question is how many IP addresses can we use, in general it will be okay. So 256 minus 2, what it is? 256 minus 2, it is 254. But again, it can be still lesser, because some of the cloud providers will reserve till to 5. Okay, so it can be somewhere in between. Okay, so it is based on cloud provider to cloud provider. But when we are talking from a pure computer networking point of view, it is 254. Okay, so the first bit usually is reserved as a so 2 bits are reserved. So first one is a identifier and the last one is a broadcast IP address. So 2 bits are reserved, but cloud providers, provider to provider, they will reserve more. So yeah, I have not considered that part, so I was trying to keep it more generic as possible. Okay, so just to understand the difference between unicasting and broadcasting. Unicasting means you are sending it to one machine or one IP, and broadcasting means you are broadcasting, you are sending it to all the IPs within your network. And again, you have a limited broadcasting and directed broadcasting. So these are just theoretical things to understand. So limited broadcasting refers to sending messages to all hosts on the same network using 255, 255, 255, 255. And directed broadcasting means you are doing it to another network, and in that case the directed broadcast IP address is the last IP address within a network, or if you have subnets within a last IP address of the subnet. Okay, so when you actually go deeper into any of the cloud provider and subnets and all those things, you will practice and learn lot on these topics. Okay, and then subnetwork or subnets. Okay, you can divide a big network into subnetworks. Okay, so it is simple. It can be for just for logical purposes, just for grouping, and it can also be for security purposes. So how can it help in security? Yeah, for Srinivas asks for cloud generally we don't reserve, but cloud provider will reserve 5. Yeah, Azure and AWS also. I think AWS also it reserves 5. But so this was so that is not mandated by the RFCs and all those things from a pure computer networking perspective. And so what are the advantages of Shruti has asked for a previous slide. Okay, so this is just two kinds of broadcasting. So you can you can send a message. Okay, you can send a broadcast message to all the directly to one IP address or directly to one device, or to all the devices in the network, and that is called as broadcasting. And it also there are few terms that we have not learned yet, like TCP/IP, UDP, and all those things. And some of these things are actually dependent on things such as the OSI model and all, so which we have not covered. So for now I am trying to keep it as abstract as possible, but we will go through these things again in detail, especially from a pure computer science perspective, after we learn about OSI model and other things. Okay, so just now, for now, know that Okay, you can send a message directly to one IP. It is called unicasting, and you can send a message to all IP addresses within your network. It is called broadcasting, and you can do it to send to another network, which is called direct broadcasting. Again, you can so every network and provider will have restrictions on who can broadcast and all those things. We will not cover it now. So, but in our AWS as well as in Azure deep dive classes on networking, so we will take these things up. Okay, and before that, either you understand OSI model or let me know and I can help you understand it. Okay, so why do you tell me any advantage of subnets, creating subnets? Any advantage that you can think about? You have a network, you have lot of IP addresses, and why do you have to cut it? Okay, easy to manage. Imagine that I have a virtual network created in Azure, or a VPC created in AWS. Okay, so what advantage will I get by dividing that network, virtual network, into multiple subnets? What advantage will I get? Easy to manage. So use your imagination. Anything. Okay, no answer. Okay, so easy to manage is just one thing, but in reduce network congestion and security. Okay, so usually evening sessions I don't take because I feel I sleep early and then get up early. But again, if you don't answer me, and then I will sleep off now itself. Okay, so yeah, coming back to so all these things are lesser important, but when you actually look from a architectural perspective in a real world use case, so some of the important things are usually you will have public subnets and private subnets. Okay, you will have some of your applications, okay, some of your servers, for example web server. Okay, web server needs to be in a public subnet. Okay, public subnet means it will have public IP addresses and anybody can access it from the internet. Okay, so your web server or your HTML JavaScript files and all those things has to be in a public subnet, so that users can access your web server from public subnet. Again, you will have additional layers of security that we will see tomorrow on top of it, but in simple terms, public subnet can be accessed from internet. But what about your database server? So is there a use case where end users have to directly access it? No, right? So end users won't have to access it directly, and because of that purpose, database servers and such things that works in background or behind the scenes are put it in a private subnet. Private subnet means it will have only private IP addresses, but there can be a connection between this public subnet and private subnet. We can configure in such a way that only this public subnet can access the private subnet. Okay, so that means if anybody can access the web server from internet, but they will not have access to the private subnet, and thus reducing the risk. Okay, if database server is exposed, so hackers if they get direct access to database, they can take whatever they want, right? So data is very important, and then if you look at many of the hacking cases that made big companies suffer, you can see that so data is it can be user data, it can be credit card, it can be any data. Okay, it can be personal identifier, PII data, it can be anything. Okay, any data is important. Okay, so that is in real projects, that is the okay. So we can combine two LANs together on the same network. All those things are there, but from a security and architecture perspective of a big application or a microservices based application architecture, So this is a very common use case. So some will be in public subnet and some will be in private subnet. Okay. And again, I told you before. So you have before subnetting you have network identifier and host identifier. Okay, and after you create a subnet, you have network identifier and also you have subnet identifier, and the combination of network identifier and subnet identifier is called your routing prefix now, and the remaining is your host identifier. So this diagram, have you understood? Is it clear? Okay, good. Okay, so again, routing, this is just theory. You can so whatever terms you don't know, you can read more or ask me post the session so that I can take sessions on those. Okay, so again, this addressing structure permits a selective routing of IP packets across multiple networks via special gateway computers called routers. Okay, sent to a destination host on another network, sent directly to a target host on local network. So there are many terms that you may not understand here, so I am not stressing on them. So routers, switches, and hubs. So there are a lot of terms that is so let me ask this question. Okay, do you know the difference between router, hub, switches, and all those things? Because if all of you know, then I don't have to plan for taking a session on that, right? Okay, no, not in detail. Yeah, some people know. And do you know about the OSI model or the TCP/IP model? Okay, yes, no, no. Okay, again, to pass the first level of exam, you don't have to know it, but once you go to other levels of exams, you will definitely need to know. Okay, I was just asking because if people are interested, ideally I should have started from that so that some of these things will be understood better. Okay, but again, so our primary focus is to focus on the current certification, and then since everybody said I have to complete this thing in this week, I was also rushing. Okay, and expressing the routing prefix, we already saw. You express it with slash. Okay, slash 24. Here 24 is the routing prefix, or slash 32 below, it is a routing prefix. And as somebody mentioned, it is also called a subnet mask or net mask. Okay, and what is a net mask? Okay, net mask is a bit mask that when applied by a bitwise AND operation. So this is where I mentioned. This is why I mentioned. You will understand if you know how to add binary numbers. Okay, so you do an AND operation of a binary number. So 1 and 1 will give 1, and 1 and 0 will give 0. Okay, 1 or 0 will give 1. Okay, so those basic things it is good to know. Okay, consider the CIDR notation of 10.0.0.32/24. What will be the routing prefix bits? Okay, what will be the routing prefix bits in this? Okay, can you answer? Okay, it is asking for the bits, not the number. Okay, 1, 10, 256, 8, 2. Okay, so the IP address 10.0.0.32 can be represented as so each of these things. So like the 10 can be represented as 8-bit, because here everything is 8-bit, right? So again, so you can, so if you do a binary operation, you will get the answer. So you can practice it out, or we'll learn. Again, this is not very important, so this is little more easier. Consider the CIDR notation 10.0.0.32/24. If you use 2 bits for subnet identification, then the subnet mask for the subnet for a subnet becomes a dash, and HID will now have how many bits? So what is the subnet mask here? Yeah, 24. And how many HID bits will it have? Yeah, 8. Okay, so was the answer correct? Okay, so what was the question? So consider the CIDR notation of 32/24. Okay, so here /24 is the current network identifier, and then if you use 2 more bits, okay, if you use 2 more bits, when I showed the diagram, everybody said you understood the diagram and there are no questions, right? So if you use 2 more bits for subnet identification, then what will be the total routing prefix? It will be 26, right? And so based on that, what will be the HID now? It will be 32 minus 26, which is 6. Okay, so again, the bigger the size of the subnet mask will be smaller, and vice versa. This is because subnet size is dependent on the HID bits, which is calculated by subtracting subnet mask. All this theory you already saw and you know. And before going to couple of more questions, so private IP addresses. So what do you mean by private IP addresses? Okay, so today's session is okay. Can you share the documentation? Okay, yeah. So yeah, all these things I will share. Don't worry, just remind me if I forget. So because this is our weekday classes or special classes are classes which I don't record in Zoom usually. So this is just whenever something is important, I take this so that you can learn. Okay, this is mostly because tomorrow we were planning to do some networking, learning around networking, security, and all those things. Okay, IPs in LAN. Okay, why do you need private addresses? Because this concept came before this 6 and all became popular, right? So the IPv4 addresses were getting reduced because internet was becoming big and big. So, and because of that, what happened? So we decided within your company you don't need to use a public IP address. Instead of that, you can use private IP addresses. So there will be a set of addresses that are reserved for that purpose. So those private IP addresses will not be assigned to any company or network. So anybody can use it within your network. But whenever you go outside, it has to be mapped to something else, and that is called something else also. Okay, so these are the ranges for IPv4 that is defined by the RFC 1918. You can just, so whenever you define for a private IP addresses even within your subnet. Okay, it is advisable to choose one of these ranges. And IPv6 also has private addresses, and it is this one FC00, and it also has another reserved set for link local auto configuration again. So that is not part of today's discussion, just for theory purpose I have put it. So those things I'll put it as extras. Okay, link local address is a network address that is valid only for communications within the network segment or the broadcast domain. Okay, and what is a broadcast domain? So broadcast domain is a logical division of computer network in which all nodes can reach each other by broadcast. Okay, so don't worry, do not don't think that I am running through. Okay, so today we are focusing only on the most important things related to IP addresses. Other things I have skipped because you need a little more knowledge. Okay, and then from next week we will have officially computer networking classes also alongside the cloud, and then we will start from basics. Okay, we will learn about things such as OSI model and all computer science networking essentials, and then this will be the second session after that. Okay, and then we will also learn about distributed computing and other things alongside our cloud and other things, because all these things are related, and the better understanding of computer science topics, the better you can learn these things. Okay, so now the question. So first person to answer will get a special if you remind me, then I will give you a special gift. Okay, so provide the range, and because until now we were mentioning only 192.168.0.0/24, and then we also said, okay, so this means it can have these many number of IP addresses. Okay, for this, and that number of IP addresses is called as the address space. Okay, it will have a start and end, and everything will be within that range. Okay, given this address 192.168.0.0/24, can anybody tell the range of IP addresses? Okay, range means it will have a start and end. Okay, 192.168.0.0/24 to 192.168.0.255/24. Okay, most of you answered it correctly. 192.168.0.0 to 192.168.0.255, and that is the range. Okay, and total number again, it is 8. No, not 8. Network prefix is 24, so HID is 8. Okay, so this calculations so do few times, and then you will be familiar, because all the theory you can learn. Okay, so I just skip, because the night sessions I don't keep it longer because I feel sleepy, but otherwise I'll if it is a serious session, then I will drink a lot of coffee, and then I will get ready, coffee or some caffeinated drinks. Okay, so yeah, so this one, based on whatever you have learned, whatever you have understood, there is this is something which we have not done it yet, but when you work on clouds, any cloud, you will need to create subnets, and understanding this will be helpful. Okay, let me see who will answer it first. Divide it into 2 equal subnets. Okay, unlike the other question, if somebody answers it correctly, because we don't have the normal quiz today. Okay, divide it into 2 equal subnets. Okay, tell me what will be what will be the prefix? When you divide it into two equal subnets, the prefix will be same. Okay, what will be that prefix? Okay, somebody is telling 28, 32, 48. The first correct answer. Okay, I need so now. Okay, so tell me only about the prefix. What will be the prefix? Think. You can use pen and paper. Okay, if you have not understood this, so then I will say again. But the whole purpose of this session was to understand how we can divide a IP address into subnets. That is why we talked about HID and all those things. Okay, so Srinivas is mentioning /28 and /28. Okay, any other answer? 26 and 28. Okay, when you say two divided into two equal subnets, it should be same. Okay, 26 and 28 will not be equal subnets, right? Whatever it is, it should be same. $12 and 12. Okay, try because use your logic, because if you can learn, okay, so forget about whatever you heard until now. If you can do this on your own, okay, so then you have learned something new. So this is because all those theory you can learn, it will be good for your future on cloud or computer science. But so this is needed for your actual subnet division in the cloud. Okay, so first of all, few things. Because in exams and all you might get options, so you can use elimination. So /24 needs to be divided into two equal subnets, or it needs to be divided. Okay, so tell me /24 or /26, which is bigger, which has more number of IP addresses, /24 or /26? Okay, so Shruti, so /24 is bigger because so the IP addresses is calculated, the number of IP addresses is calculated from the HID bits. This is the NAD bit. So whatever it is a complement. So if it is 24, then you have how much? 8. If it is 25, then you have 7. If you have 26, then you have only 6. Okay, so the number of IP addresses will reduce based as the routing prefix increase. Clear on that? Okay, so now you have only few options. So what are the options? The options are 25 to 32. Okay, first level of elimination is done. So two equal parts means it has to be less than this. Okay, so that means it has to be 25 to 28. Okay, so I'll give 1 minute for you to think. Okay, so if you think and do it on your own, it will be very good. Try, think something, because this is one thing that will really help you. So especially when it comes to AWS security specialty or networking specialty or the AUCET 500 or even the architecture exam in Azure. Try, at least I want one person to give an answer. Okay, so Have you given up? If you have given up, then you can say GU and then I will help you derive it. Okay, GU. Okay, so now I will ask few questions. Okay, let me okay, I will ask few questions. Okay, if you have a /24 as the routing prefix, how many IP addresses can you have? Two to the power 8, which is 256. That everybody is okay, right? Okay, 32 minus 24 equal to 8, and 2 to the power of 8 is 256. You are clear? Okay, now what is half of 256? What is half of 256? 128. 128 is 2 to the power of what? (256) is 2 to the power of 8. So 128 is 2 to the power of 7. Yeah. So okay. So 128 is 2 to the power of 7. So half is 128, right? So if the HID bits is 7, okay, 2 to the power of 7 means HID bits is 7, right? If I need HID bits to be 7, how many bits will be there in the NID part or the routing prefix? Yeah. Now all of you are mentioning 25. Okay. So it will be /25. Understood? If any of you have not understood, tell now, because this is the most important thing. Okay. So now because not at least one person answered this question correctly. So now everybody are clear, right? Okay. So it is simple. You have 256 and then the subnets will be /25 and /25. Okay, it is very straightforward. Hope you understood. And so this is the bumper question. Okay, so this question, whoever answers it first will be the main winner for today. Okay, so tell me. So now you know all the things. Now you know the logic. Okay, you need to divide it into 3 subnets. Okay, first subnet should be 64, second subnet should be 64, and third subnet should be 128. How will you divide? Are you trying or waiting for me to tell the answer? If you are trying, at least say okay. Okay, everybody send it to all panelists, because all of us are learning. Not all panelists and attendees. Okay. So don't send to me alone thinking what will others feel, because everybody are in the same situation. Everybody are learning together. Okay, try. Because usually we'll have some cues, and then most people can say choose one of them. But here we'll be using little bit of. Usually I will be also practicing alongside you, but I am not able to find my pencil, and my kid is playing with my iPad. So I went and checked with her, but she gave me, but she didn't have the pencil. Okay, let us go one step at a time. If you need to have 64 Okay, 64 is 2 to the power of what? Yeah, 2 to the power of 6. So it should be slash what? Okay, slash 26. And 128 is 2 to the power of what? You already saw that. It is 2 to the power of not 8, 2 to the power of 7. Okay, and what will be slash? What will be the routing prefix? It will be slash 25. So first one will be slash 20. So first one will be slash 26, second will be slash 26, and third will be slash 25. Okay, 26, 26, 25. Okay, so now that part is clear. So now what will be the IP address range here? Okay, first one, start, I will tell you. 192.168.0.0 198.168.0.0 slash 24 will be the start of the first subnet, right? Okay, so okay, my yeah, I accidentally typed 24. Okay, forget it. Okay, yeah. So what will be the start of the first subnet? It will be and it will be whatever I so 192.168.0.0, right? And what will be the start of the second subnet? Okay, it will be 64. And what will be the start of the third subnet? Okay, okay, first will be 0/26. So second will be so subnet is denoted by the first. Usually it is denoted by the first IP address of that subnet. Okay, the answer will be first one, the start of first subnet will be 0.0, but when you represent it as a address space, you say 0.0/26, and second one will be 64/26 when you represent it as a address space using the CIDR notation. The start IP will be 192.168.0.0, but /26 will make it the address space for the whole thing. And the third one. Okay, so clear? At least an yes. Okay, so practice more and more in our networking session, not tomorrow's networking session, but in when we actually learn more about the networking in AWS or Azure, then we will do more and more exercises. And even if how many of you will be interested for the computer science series? I just need a yes or no. If people are interested, I'll do. If okay, because currently what I have planned is three things. So one is the computer science essentials, like OSI model and TCP IP model and all those things. And so then we will see this IP address thing again. Okay, so along with that models, we will also see router, switch and hub and all those things. And then we will see the IP address again. And also another thing I would like to do is distributed computing, because these days okay, yeah, so I am starting from next week. Probably I will send a message, and if people are interested, at least more than 10, because in our actual sessions we will have our quizzes also. So if people are there, I will start from next week itself. Have you learned anything new today? And do you think, because this was not a planned session like our cloud and all, but still, have you learned anything good today? Okay, thank you. Okay, actually that motivates me to continue. Okay, so this is my so I was thinking of what name I'll give to again. If you go to csccafe.com, you will not see anything. I just got it. I designed a logo, and so this is the plan. So sometimes when you work on cloud or other things, so there will be a lot of concepts that you need to learn. So I realized that while I was taking cloud computing sessions on networking, security, data analytics, DevOps, and all, so people do not have enough computer science knowledge. Okay, so people are trying to take the data platform certification, but when I asked because people have come with the certification logo and all in their resume, when I ask about things like as cap theorem, they don't know. Okay, and because clearing certification, as you know, like you can do it with dumps, but so these real interviewers will be checking whether you have real knowledge of computer science topics. So that matters more. Okay, so distributed computing is again very hot topic today. Cloud itself is based on that. So we will learn all those things based on interest. Okay, I will ask you, and if you are interested, then I will take that. And our keep in touch. So this is a unofficial special class. So weekdays I call it a special class. So just to talk on something which is outside of our normal syllabus. Okay, bye bye.